In this lesson, and in this series of lessons, we introduce you to the concept of data structures. Data structure is the most fundamental building block in computer science, and a good knowledge of data structure is a must to design and develop efficient software systems. So let's get started. We deal with data all of the time, and how we store, organize, and group our data matters. Let's look at some examples from our day-to-day life where organizing data in a particular structure helps us. To be able to search a word efficiently in a language dictionary because the words are sorted. What if the words in the dictionary were not sorted? It would be impractical and impossible to search a word among millions of words, so a dictionary is structured as a sorted list of words. Let's pick up another example. If we have a city map, the data for landmarks and road network connections. All of this data is organized in the form of geometries. The map shows the geometries on a two-dimensional plane. So map data needs to be structured like this so we have scales and directions and effectively be able to search for a landmark or an effective route from one place to another. And I'll pick one more example. Like daily cash-in, cash-out statements of a business, it makes more sense to store the data in a table or schema. It is very easy to aggregate data if the data is stored in these columns, so different data structures are needed to organize different kinds of data. Now, computers work with all kinds of data. Computers work with text, images, videos, relational data, and pretty much any kind of data that we have on this planet. How we store, organize, and group data in computers matters because computers deal with really large data and the computational power of the machines, and if we do not use the right kind of logical structures, then our software systems will not be efficient. The formal definition of a data structure. A data structure is the way to store and organize data in a computer so that it can be used efficiently. When we study data structures as a way to store and organize data, we study them in two ways. We talk about data structures as mathematical, logical models. When we talk about them as mathematical and logical models, we must look at as an abstract view of them. We just look at them as a high level. What are the features and what operations define a particular data structure? We refer to the mathematical and logical model as abstract data types. An example of abstract data type would be, I want to define something called a list that should be able to store a given number of elements of a particular data type, and we should be able to read these elements by position in the list and be able to modify an element at a particular position. Now we're just defining a model now. We can implement this in a programming language in a number of particular ways. So this is the definition of abstract data type, commonly written as ADT. If you see all high-level languages, they already have a concrete implementation form of an ADT in the form of arrays. Arrays give us functionality, so arrays are concrete data types. Implementation. So the second way we talk about data structures is talking about their implementation. Implementation should be concrete and not abstract type. We can implement the same ADTs in many ways in any language. For example, in C or C++, we can implement this ADT using a data structure called a linked list. If you have not heard about it, we will be talking about it a lot. So let's define an abstract data type formally because this is a term that we will encounter quite often. Abstract data types are entities that are definitions of data and operations but have no implementation, so they don't have any implementation details. We will be talking a lot about data structures in this course. We will be talking about them as abstract data types, and we will also be talking about how to implement them. Some of the data structures we will be talking about are arrays, linked list, stack, queue, tree, graph, and the list goes on and on. there are many more ways to study. When we study these abstract data types and data structures, we will study their logical view, what operations will be available to us. We will study the costs of operation in terms of time, and we will study the implementation in C language. Until next time, see you.